We'll see once what we have done in the last classes. Once again, we have completed our first chapter, Introduction to DCN, Computer and Data Communications, DC. We have completed data flow, network, distribution of all the things, OSI model. OSI model is the very important model. Every year you are going to get at least one question from this OSI model. At least 8 marks you are going to get from OSI model, and it is the base model for all the computer networks. Most of they are using this OSI model, right? Still they are using OSI model only. Okay. In the second chapter, what we have discussed: links, access networks, LANs, introduction to link layer, services by the link layer, types of errors, redundancy, detection versus correction. Today we are going to discuss all these things only. In the second chapter, we are going to see what are the links, access network to the LANs, and introduction to link layers, services provided by the link layer, types of errors, redundancy, detection versus correction, forward error correction. I am not going to deep enter into all the sessions, but somehow I will explain reasonably. We will move on. Otherwise, it will take one more week or 2 weeks to complete all this one chapter. Okay. If you have any doubts, you can ask now. Give me a minute. I will share chart. Where is the chart? Okay, I'm keeping this in the right side so that I can. I haven't started ma. Once I start, all the students comes, then I will start my recording also. Give me some more time. Only 83 students have joined. Give me 2 minutes more. After that, I'm going to start my session. Today's session. And today onwards, next classes onwards, we are going to discuss every day a new topic which is useful in your daily lives. Okay, at what time I'm going to discuss, I am not going to tell you, because of making your class interest more interest. For the sake of that particular purpose also, the students will join and they listen classes properly. So every day I'm going to discuss something new which is not relevant to your J2 syllabus, but it is mostly useful in your daily life. How your hacking would happen, how Bluetooth will work, or some small topics we will take, not more than 3 minutes or 5 minutes. I'm going to explain how it will work, how the data is transferred from one place to another place in the NFCs. Like right now we are using NFC, near field communication. How many of you know about this NFC, near field communication? If I say near field communication, no one will say, "Sir, I know near field communication." Tell me, please respond yes or no. Near field communication. Most of you have used this particular thing in your malls, favorite restaurants. Can you hear me, ma?
Chat is disabled.
Give me. Yeah, now you can chat, I think so. Participant can chat with everyone publicly and privately. Please respond ma. Okay. Yes, we have it in mobiles too. Okay, that's good. I'm getting correct answers also. Whenever you goes to your mall or while you are paying bills, your debit card or credit card will have this kind of facility, near field communication. Whenever you are not going to swipe your debit card or credit card, just when you touch your credit card to your that swiping machine, that POC machine, point of sale, POS, point of sale machine, it is going to access, it is going to get the information in the form of packets from your device, your credit card or debit card, and it is going to your money will be debited or credited from your transaction, and it is going to deposit it into that point of sale device, so that particular seller's account. Okay, this is nothing but your near field communication. We are going to see one after another in the daily classes, daily basis. We are going to see, not I'm not going to take more than 5 or 10 minutes for these kind of things. But it would be more interesting how it will work, how possibly there may be a chance of hacking, how they are going to, how you are going to protect yourself, this kind of, while you are using this kind of things. Okay. uh, Nearly 90 students participants has joined, so I'm going to start my session. I'm going to record first. Yeah, I have started, I think. Okay, now today we are going to see about introduction to link layer. In last class we have discussed, in last sessions we have discussed about link layer, which what is a link layer, which layer it is, in top down approach or bottom up approach, which layer, first layer, second layer, or third layer? Do you remember how many layers would be there? Please. 7 layers. Okay, what are they? 7 layers. What are they? Oh, sorry, it is not, should not be. APS, TNDP. Okay, these are the, whenever I'm saying APS, TNDP, application, presentation, session layer, transport layer, network layer, data link layer, and physical layer. Okay, that are the 7 layers which I have already told you to, that APS, TNDP, you have to remember by heart. Whatever you want to do, you do. That is the 7 layers of your communication, data communication. Okay, we are in link layer, that is the, in the bottom up approach, second layer of bottom up approach, second layer after physical layer, below the network layer, below the network layer. My data link layer will do, it will take that information from the network layer. Upper layer is nothing but your network layer, and it will formulate for the there are some responsibilities are there for your data link layer. According to that responsibility, it will do some work, and it will forward the data in the form of frames. It is going to, whatever the packets come from the network layer, it is going to, we are calling in data link layer as a frame, and we are going to data encapsulate the datagram into that particular data link layer, and we are forwarding to your physical layer. Okay, in data link layer, we are hosts and routers, whatever the devices, either it is a mouse, or it is either it is a laptop, your mobile phone, router, whatever that thing, we are considering it as node. Okay, links. What is a link? Please respond me. You can see here also on the screen link. These are the basic things you have to be careful. A link is nothing but a channel between two adjacent nodes. Either it is mobile or device, mouse and your computer also. It is a channel, and along with your path. Whenever I'm clicking a mouse also, it is going to send a request to my system from one-way communication. Okay, from my mouse to my system, not from the my system to, I am not going to get the reply from my system to mouse. Okay, my mouse to my system, I am going to generate a link link between these two things. Okay, a link is nothing but it is a communication channel that connects two adjacent nodes along with communication path. So whenever I'm clicking on my mouse, I am going to send some signal to my system. So it is the, I know how where to send also. Why? My cable is connected to my system. That's the reason it is going to send to that system only. It is not going to send my signal to another system. That's the reason the communication path is also available for that particular thing. So there are types of this: wired links, wireless links, and LANs. Okay, wired links. How many of you have remembered that how your network will work? How your network will work? If I am using any cable, Act Fiber Nets, I got a cable from Act Fiber Net. I have a cable. I can generate multiple connections. I can generate a LAN also in my home, because with the help of this LAN only, I am going to generate a simple network, a small network in your home. I can use for the single link. I can utilize the many number of devices in my home. Otherwise, what will happen? Whenever I get the single cable, I have to use either it is for with the desktop or with the laptop or with the mobile. Without creating LAN or the a network, a simple network, a home based network, I'm not going to use all the devices into that particular thing. With the help of a router, that is also a node. With the help of router, it is going to communicate each and every device of your home, and it is going to forward to the particular things. Okay, next, DLL. Data link layer has the responsibility of transferring the datagram from one node to another adjacent nodes over a link. Okay, it has the responsibility, and it has some more different responsibilities. From here you can see here one router to, there are three networks, different networks I have. In the left hand side topmost network, in that two mobile phone, two landlines, and two computers, one router, two servers are there. Okay, these routers, this first LAN is connected through a link. From this router to this router, I have a link means I know, from whenever I am sending a message from this computer to any other networks or the outside the world, I know how to send. Okay, when I am sending a request from this server or this particular machine to somewhere else, I know how to go from here to my router to the next LAN, which is present in my home or in my adjacent building. From that to that LAN, from that link LAN, that router to, it is going to forward the different paths, and it is going to, at the end, it is going to reach at the last network, that is the your home network or some other network, destination network, and it is going to reach that particular thing. There are something I want to discuss. First, physical layer, logical layer, physical address, logical address, and framing concept. These are the responsibilities of your data link layer. First one is framing. Second, physical addressing. Here, while you are sending a mail or message to someone else, while sending, you don't know the physical address of your device, either it is laptop or your desktop or your mobile. You don't know the physical address of that particular destination, but you know the logical address. Who knows these physical addresses? The device which is connected in the network, which is directly communicating with outside world. That means in my home I have a router, a small router is there in my home. My router knows what is the physical address of each and every mobile or device of that particular network. No one knows. Why? If the physical addresses, if you are going to keep in your disk, it is going to more than 600 millions of devices would be there. For each individual device there may be having the different physical unique physical address. How come I search? It is very difficult. That's the reason we are going to use logical addressing, which is taking care by your network layer. You're taking care by logical addressing, that is 10.11.36.19 or some other IP addresses, 192.168, whatever the logical address. That logical address, you can have that particular thing and you will send that logical address to that server according to that. And the end devices or your routers, it is going to consider your logical address and it is going to match with physical address. To that particular system only we are going to send the message properly without any disturbance. Okay, there are two more things: flow control, error control. What is flow control? My server can send thousands of bytes of data at a time, but my receiver can take only 2 bytes of data at a time. Why? My mobile or my device is low end device, it can access my cable and all the things are very smaller thing. So whenever it is going to send the 1000 GB of data at a time, but my device cannot access 1000 GB, only 10 MB or 20 MB data at a time it is going to take, and it is going to save in that case. What will happen if the server sends the 1000 GB of data at a time also? It is going to happen, a bottleneck will be available, will be happened in the cable. So everyone will be stopped, that particular cable they can't access properly. That's the reason we are your data link layer introduce flow control. And next, error control. There may be the data is transferring in the form of bits and bytes only. Whenever you are sending one bit is nothing but your up power transmission, up signal, and the zero is nothing but low signal. That is only we are thinking. When you are sending there may be a chance of having power issues, or there may be a chance of having some different kind of issues to alter that up signal to low signal, low signal to up signal. That means whenever you are sending that thing, it will, your data will be modified. We are going to get the wrong message. So your data link layer is going to responsible for these errors, how you are going to access these errors also. Okay. And media access control. I have a cable, a very strong cable in my company or organization. That cable can access thousands of that cable can be accessed by thousands of devices. Okay. Even every time thousands of devices are sending it, I must know when is this particular medium, that link is free, when is that particular link is busy. Otherwise, whenever I'm sending the data, that will be collapsed, and there may be a chance of penetrating that two different datas into that particular device, that particular medium, and it is, you are going to get erroneous messages at the receiver. That's the reason your data link layer is doing media access control. That means the cable or the link control it is going to do on that particular thing. Because of these five things only we are going to learn link layer. Okay. Link layer, we have whatever we have done, this is we have already discussed error control, flow control, media access control, all the things. Next, framing, how you are going to do the frame. Okay. Whenever, what is the need of framing actually? I want to ask you a question. Why we need framing in DLL? Most of you have remembered the thing. I'm expecting some, at least some of the people will respond on framing. If I'm not going to use framing in this situation, or your data link layer is not using framing, what will happen? What is the biggest disadvantage when you are not using framing? At least any one of you, please respond. Ma. There are 96 students out there. If I am not cut my large amount of data into small units, what will happen? If I forward large amount of data as it is to the receiver end, what will happen? The basic thing, why we need framing. If you know why framing is a need, then you come to know how to access, to know whether our data is corrupted or not. Okay, good. That is the one thing. Next, any other answers, ma? In that also, there are some more answers are there. To identify sender and receiver address. Okay, the basic advantage is, if I have 1 GB data to transfer from A to B. Okay, 1 GB data to A to B. First thing, if I am sending directly 1 GB data into one packet, I am adding the sender address, receiver address, and all the things, and I'm stuffing in that particular packet and sending. At the receiver end, he got the total 1 GB data. He finds that in that 5 MB of data is missing, misplacing. Okay, what we'll have to do? Either you have to resend the data of 1 GB, or you have to correct at the receiver end, has to guess or correct the data whatever the received 1 GB data. In 1 GB data, if you want to find out the 5 MB data to modify, and you have to check each and everything, it will take 3 to 4 days time to rectify that particular data, 1 GB data, to rectify only that particular 1 GB data. To recover this, to not not getting this kind of issues, data network people, what they did, first of all, whatever the data it would be, we are going to we are going to cut the data into small pieces. Cut the data into small pieces. For each piece, we are going to add the from address, to address, and the and header and trailer also thing, also as well as flag kind of thing to my data. What is the need of this flag? Where the data is starting, I am sending the data one after another. That means 1 GB data I am going to send. Okay, 1 GB, whenever I am sending 1 GB data from A to B, but I am modifying that 1 GB data into small pieces with the help of flags, header, trailer, and payload field. Payload field is nothing but my data. Okay, header and trailer will have sender address, receiver address, and all the things. Flags, when my data is going to start, that is payload data is starts, that is going to divide my data into these flags, so that your your data starts here and your data ends here. For that purpose, we are going to make the frame. Okay, how many ways you are going to frame the data? There are two ways: byte stuffing, bit stuffing. Okay, framing can be done in two ways, that is variable size framing, fixed size framing. Okay, in fixed size framing there is no need of having anything. Every time 1 MB of data I am going to send. In this case I need not to have the flags. Okay, my payload size is 1 MB only. So every time I'm going to send 1 MB. So after 1 MB, you have whatever the data you just discard and get the data simply. Okay, if it is very fixed size, I do not have any problem. But there are just so many priorities will come from one user to another user. One person is going to send only 2 KB of data, but he is waiting for 1 hour or 2 hours to that particular other person has to finish his 1 GB data transmission. That's the reason we are coming with variable size framing. Okay, variable. The other time is whenever you are using large data, there must be a having 1 MB every time 1 MB. That means 1,000 minutes you have to wait to complete all the data. That's the reason we come up with variable size framing. That means I don't know whatever the data is there, it will convert the data according to your need, and it will have the variable size framing with the help of putting flags at the both the end of that particular character stuffing and bit stuffing we are going to use in this particular thing. What character stuffing will do, we are going to add one ASCII character at the front and the end of the particular flags. Okay, okay, header and header that are different. Header you are going to have the from address to address all the things. In flags we are going to have the ASCII codes, either A or B, whatever you want to keep you can keep, but there must be a chance of having different things. If I finding same character flag character in between my data, it is going to think this is the end of my data, so I have to discard. I am not going to take the afterwards data. For that, to fix that particular issue, we are going to add that one escape character for matching data which is with your flags, end flag and starting flag. Okay, escape character we are going to. What the escape character will do? Whenever you are going to find the escape character, here you can see byte stuffing. Whenever you are going to the character with the same as flags, it is going to add a new character, escape character into that particular thing. At the end, the receiver will remove that escape character and read the proper information. Okay, in this also there are some of the differences would be there. If you are finding two escape characters, in that case what will happen, and what happens whenever errors will come, we are going to there are two different disadvantages in this particular thing. We are universal coding system, unicode system we are using. If he wants to add some other language, Telugu, Hindi, English unicode characters, in that case what will happen, it is not going to understand that particular thing. We are not going to whenever I am trying to transfer the audio video files, in that case also we are not going to stuff our characters, in this case audio video files and unicode systems. In that case we are not going our character stuffing or byte stuffing won't help. In that case we are going to have the bit oriented approach. How the bit oriented approach will help? We are going to stuff 0 triple 1 triple 1 0 0 triple 1 0 triple 1 0 8-bit pattern flag we are going to add. Whenever you are finding, here also we can add, sir, here also we are going to find the same kind of data, how it you are going to find. In this case also we are going to, after 5 consecutive ones, we are going to add extra 0 is added to that one particular thing after 5 consecutive. But in case of header and your flags, starting flag and ending flag, it is not going to add. Only in that data payload, it is going to add extra 0 after 5 consecutive ones. If I am going to find the 5 consecutive ones, after that I am going to add 0 extra. Whenever the receiver understands that, it is going to remove that 0 and it is going to read the proper data, and I can forward audio, video, image files also without any issues to the receiver end with the help of bit stuffing. Okay, are you clear, ma? Any doubts in this particular thing, framing kinds of thing? Use the simple example for byte stuffing and bit stuffing. Here, delimiter. Good day, I am sending good day. My delimiter, starting delimiter is D and ending delimiter is G. Okay, good. Here you can see good day, but my ending delimiter is D. That's the reason it is going to add the flag, escape character. In the case of D, it is going to add one more D, and in case of D again we have D again, so it is going to again adding the escape character. Okay, at the starting and ending we have starting character, ending flag, and we have G also here in the payload. So I'm going to one more escape character for G also at the receiver side. Anyhow receiver comes to know, okay, I'm getting two things, so I have to remove this. Okay, any doubts, ma, this one? Without wasting time, I'm going to start the next thing. Please, if you have any doubts in this particular thing, you can ask. Next, in next slides we are going to see, we have discussed error. What is an error, types of error, redundancy, detection versus correction, forward error correction versus retransmission. What are the things we are going to see. First, what is an error? Error means whenever I am sending 101 to the receiver, if the receiver receives 101 exactly, in that case you do not have any problem. If the receiver receives either not that 101, if he is reaching 111 or some any other thing, it is called it as the error. The total message is wrong message. We are not going to understand that particular message properly. We are going to utilize the if they use, that is no, it is a erroneous, that means error. Either it is a single bit or busty errors. The types of error is nothing but single bit error or busty error. If you are having more differences in the total data, that means 0 to 1, 1 to 0, that means more number of bits has changed from that particular place, that is called as a busty error. In the communication networks or computer science, either it is a single bit error or busty error. There is no chance of having light. Okay, either it is a single error or busty error, you have to consider it as a error only. You are not going to utilize that particular proper message. Otherwise what will happen, if you are sending 3 to that particular 3001 as a password to the user, but user thinks that if you are sending either was one single bit also, it is going to change your number 30012 to 3002. You are not going, he is not going to open his mail or his particular application. That's the reason there is no kind of single error, or there is no difference between single bit error or busty error. Okay, next, redundancy detection. Redundancy. First of all, to detect or correct error, we need to send an extra bit with the data. Okay, whenever I'm sending, it is either it is a bit error, single bit error, or bust error. What is, how I am going to find this particular message is proper or not. Authorization or authentication, how I am finding that this particular message is proper message. With the help of redundant bit or redundant bits, we are going to find my whatever the data is came to me, it is the proper message. Okay, with the help of redundant bits, we are going to find the where the authorization I am going to give the this particular message is proper message, this is going to the faulty message. Okay, next, detection and error correction. Detection is nothing but whether the particular method the data is error free or not, we are going to find out with the help of redundant information. I'm going to find this particular data is error or not. Okay, correction is nothing but with the help of some extraction methods, we are going to either guess the particular thing, or we are going to modify our data according to our needs. So this is nothing but you're correcting the errors and you are reusing the same data with the erroneous with the help of some techniques. Okay, that we are going to see in the next things. Okay, error detection is nothing but you are going to find the whether the data is corrupted or not. Here correction in that we are going to modify the bits and we are going to use the data with the proper solution. Okay, detection and correction. Next, forward error correction versus retransmission. In this process, the receiver tries to guess message using redundant bits. Forward error correction, in this, he is going to guess the actual data and it is going to use that particular data. Retransmission. It is used in the small errors, not the busty errors. Retransmission. If you are finding any error in that particular, just simply throw that data into dustbin and ask the users to retransmit sender to retransmission. This is the next thing you are going to use in the retransmission. You just throw the data into dustbin and ask the sender to retransmission. Coding and decoding. Whenever your data is transmitting with the help of generator, you are going to encode the data, and at the receiver with the help of checker, you are going to re-get the actual message, decode the actual message, and you are going to get the information. Here generator will add the redundant bits to your message and redundant bits you are going to get as a encoding. At the receiver end, receiver will get the actual information with the help of checker. It is your checker will remove the redundant bits and check whether the given information is proper or not with the help of checker. Okay, block coding. In this we have discussed all the bits, how you are going to data words code. You just read out all the ppts I have already shared with you. Just I'm not going deeply in the block coding each and every application. Just how the data will be transmitted and generated in bits, that I am going to discuss simply. Okay, if you have any doubts, please make a call or you can whatsapp me. I will arrange whoever have the issues, you are not able to understand any protocol in this particular session. Okay, I will in the afternoon section we are going to have a small meeting. In that I will discuss. Don't waste others time. Okay, more than 90 100 members are logged in, so I am skipping this all the detailed information. Just what I want to explain. Okay, error decoding encoding, this is the thing where you are going to add the new bits. Parity check. What is parity check? I am going to add the even parity or odd parity. Whenever I am finding the number of ones in my data word is odd, in that case I am going to add one more one to make it as the even parity. Okay, I have to make it as even parity. Otherwise what will happen, I'm not going to find with the this is a technique to find the whether the information has any modifications or not. Even parity check or parity check. Okay, having distance. Having distance between the two words is nothing but number of differences between the corresponding bits. That means I have, okay, I will explain you one thing here. XR, you are going to having distance, in that you are going to do XR operation, 000 XR 011. The Hamming distance is 2. Why? The two number of bits has changed from the in that particular location, from first data word to second data word. Okay, that are the places 2 and 3. That 1 and 2 places have been modified from this place to this place. With the help of XR, I am going to find the Hamming distance between that particular thing. Hamming code, you have to check. Okay, okay, this is the Hamming code. Hamming distance we have already discussed in that particular in last sessions. You just review once again how to do Hamming distance, all the things, and how we are going to find out the errors in data transmission. Okay, this is the, if anyone have any doubts, please let me know, ma. Sometime. There are so many error detection and correction techniques are there. Simple parity check, two-dimensional parity check, checksum, cyclic redundancy check. We'll discuss one after another one. Simple parity check. If it is modulo to operation, arithmetic modulo to arithmetic operation, I am going to do in simple parity check. If I am finding odd number of ones, if I am finding odd number of ones, I am going to add the 1 at the end of the term. Simple parity check. You must remember that we have discussed this thing long back. If I am finding the data sender word is having odd number of ones, in that case I am going to add 1 as a 1 at the end as a redundant bit to make my data as even parity. To make the my data as even parity, so that at the receiver end understands that this contains, system contains the even parity. So I have to remove the last bit. Even parity, if the receiver receives the even parity, that means the data came properly without any issues. So it is going to remove the last redundant bit and it is going to get the proper information. If the data has changed in middle, at the receiver end it is not going to find the even parity, so it will just discard the data or try to guess that particular data. Okay, correction in the error correction mode, two-dimensional parity. In this case, there in rows wise and column wise, he is going to add the parity bits, redundant bits, to make the even parity. Here you see we have odd number of ones, so it is going to add 1. Here we have even number of ones, he is going to add 0. Okay, even number of ones, even numbers, odd. This is a two-dimensional parity check. Okay, checksum. In this ones complement we are going to arithmetic, ones complement arithmetic we is going to use, and is going to add the sum with the help of checksum mechanism. Here he is going to add ones complement ones, all the things, and he is going to get, while receiving that particular data, if he is not going to find the proper data, he is going to just simply discard that particular data, and it is he is going to ask the receiver to retransmit the data. Cyclic redundancy checks. In cyclic redundancy check, we cyclically we are going to shift the data to the right to left. Here your data word is 1011 000. Okay, I have shifted one bit to the right side. Okay, all the characters would be moved to left, and the first character will go at the end. Okay, at the receiver end, cyclic redundancy check, how many times, that is you define that particular thing. According to that, we are going to receive at the receiver at also, and also he is going to rotate, shift the cyclically he will shift the bits to the rightwards, so that he will get the proper details. Okay, here you read out all the things ma. If you are finding any problem in that particular thing, we will discuss again. Okay, individually I am going to discuss, not in the class. Okay, devices, CRC, this is also one of the important things, CRC, cyclic redundancy check, in your second unit, cyclic CRC. Okay, division in the CRC with decoder 2 cases. Okay, next polynomial representation, we have seen this one also. Okay, next flow control protocols to stop the flow control flow flow of transmission from sender to receiver. We use flow control protocols. For flow control, we are going to have the acknowledgement from the sender to receiver to sender. Whenever I'm finding that acknowledgement from the receiver to sender, I come to know the data is transmitted properly to the receiver. With the help of acknowledgement, we are going to control our flow. If I am going to find the acknowledgement only, I am going to resend, I am going to send more data to the receiver, otherwise I am not going to send. Okay, this is called flow control. If I can send multiple data, that means 1 GB data at a time, but without knowing that the data is transmitted to the receiver, and without knowing that, I am not going to resend that data next data, so that my data, the flow of that particular transmission would be safe and secure. Okay, error control. If you are finding any damage, frame loss, we are going to either retransmit the data, or at the receiver's end he is going to guess. Okay, if he is guessing, he is going to send the acknowledgement. If he is capable of guessing that, but if it is small data, then only he can guess. If it is the large data, he cannot guess, he will just simply ask for retransmission. Okay, okay, he is asked for, he coordinates with the sender and he asks for retransmission. That is nothing but automatic repeat request, ARQ. With the help of ARQ, automatic repeat request, he is going to ask for retransmission. He will send the retransmission. Okay, there are so many protocols are there for error control. Okay, and flow control, not error control, flow control. Error control and flow control both are mixed up. Mixed up means I'm not saying that is the both are same. Flow control is nothing but you are going to find out the data is transmitted properly, transmitted flow. In flow control, we are data is transmitted or not, we are going to see. We are not concentrating on whether the data is correct or not. In error control, we are going to find out the data is transmitted properly and correctly in the error control. Okay, both are the responsibilities of your data link layer only. Okay, here we are divided the protocols into noiseless channels and noisy channels. Noiseless channels means there is no error kind of things. This is the ideal channels. We are not going to see anything. That means error won't be happen. We are assuming that never then error won't happen. in the noiseless channels. In noisy channels, there may be a chance of error correction. Error would be happening. We are going to find the we are going to have the error correction and error retransmission of the data mechanism would be available in the noisy channel. In noiseless channels, we are not going to retransmit. Simply, we are sending the data and we are leaving that particular channel. Okay, these are the noiseless channel. We are assuming that there won't be errors, but in noisy channels we are having the error detection and correction mechanism in that particular flow control. Okay, these two are the flow control mechanism, but in flow control mechanisms in noisy channels we are going to check the error correction, error detection also, but in noiseless channel we are not going to see that particular thing. Okay, simple protocol. There in real world there is no noiseless channels. Okay, we have ideal channels. The same thing we have seen here. You see, sender get data from the network layer to data link layer, simplest channel, and wrap up the data and send the site. We are going we are not going to do anything, just getting the data and we are forwarding the data to the receiver. We are not doing anything. This mechanism will run forever. Okay, request from the network layer means I'm going to get the data from the network layer and forward the data to the physical. I'm not doing anything, just making the adding the things and I'm going to send it. That's it. I'm not going to do anything in the simplest protocol. Stop and wait protocol, simplest protocol. Here this is also simplest protocol. Here sender will send the frame, receiver receives. That's it. I'm not going to check whether the data is transmitted properly or not. Just sender sends, receiver receives. Stop and wait protocol. In stop and wait protocol we are going to see, I will send a frame, I will wait for acknowledgement whether the particular data is transmitted or not. I'm going to check for that particular properly say. If in the simplest protocol we are not checking whether the data is reached or not also, but in the stop and wait protocol we are going to check whether the data is reached properly, whether the data is reached or not. If it is reached, not a problem for me. If it is not reached, in that case I'm going to retransmit the data. Okay, I'm going to retransmit the data in stop and wait protocol. Until unless I'm going to acknowledgement, I'm not going to send the second. Okay, in this you will have some problem. If you have sent the frame to the receiver, but receiver has sent acknowledgement also, the acknowledgement has discarded. That means meanwhile it has lapsed or some time will happen. There may be a issues with the in noiseless channels. But in case of noisy channels there may be someone hacked that particular acknowledgement. What will happen? You will wait until the acknowledgement comes of arrival, otherwise you are not going to send. With the next protocols, noisy protocols we are going to see. Stop and wait automatic repeat request, go back automatic repeat request, selective repeat automatic request. In this I will show. Okay, after some time if I am not finding the acknowledgement, after some time I am going to activate my timer. Here I am going to activate my timer while I am sending the data to the receiver. First I will wrap up the data into frame. Okay, whatever I got from the network layer, I will wrap up that particular thing into my frame and I will transmit the data to the receiver. While transmitting the data I will activate my timer for 10 seconds or 15 seconds. Meanwhile, if I did not receive any data from receiver to me, I will, after that particular 10 to 15 seconds, I am going to retransmit the data without waiting for the acknowledgement. Okay, this is the next design. Here we are going to have the sequence numbers, stop and wait AARQ. Why I am using stop and wait ARQ? In this, every time I am going to send one after another, I am going to send the frames. Okay, stop and wait ARQ. First frame I have sent. If I get the acknowledgement, not a problem. Next, in the second scenario, you see sender sends the frame, but say frame has lost in middle. Okay, after timeout only senders resends the frame. Okay, he got the acknowledgements. Okay, next, in the third scenario, sender send the frame, but I did acknowledgement has lost in middle. Okay, after some time, he after the timeout, the sender resend the frame and it will receive the acknowledgement. Okay, fourth scenario, in the sender in the stop and wait ARQ, sender sends the frame waiting for acknowledgement. Meanwhile, timeout, before reaching the acknowledgement, timeout. So automatically sender resends the same frame to the receiver, and he will regain the acknowledgement from that particular same packet. Okay, this is a stop and wait ARQ. Here is the flow chart for stop and wait ARQ pipeline. This is a new concept, pipelining, not new concept. Pipelining is nothing but whenever in network any multi-processing, multi-threading concept, if you know, whenever you are doing some work, after before completion of that particular work only, we are going to start new task. In networking also, a task is often begun before the previous task is end. Why? He should not wait. He should not waste his time. In networking, time is the most precious thing. Because of time is most precious thing only. That's the reason the network, the data communication has the vital role in your daily lives. Okay, the pipelining is nothing but before starting the ending the first task completed, we are going to start the next task. Okay, this is nothing your pipelining. There is no pipelining in stop and wait ARQ, but go back ARQ and selective ARQ use pipelinings. Okay, next protocols, noisy protocols, we are going to go back ARQ. Okay, we are after this I am going to stop the HDLC and multiple access protocols. We are going to discuss this after multiple access. We have to start with multiple access protocols, multiple access thing that we are going to start in the next sessions. Go back automatic report and selective repeat. In this, there is two things before pipelining is going to start, and here you see how it will work. When the first sender is going to send the message, the first receiver receives the particular frame 1, frame 2, frame 3, and sliding window protocols we are going to use in this particular. So frame is going to slide from one place to right, left side to right side. Once the it completes that correctly received all the three things would be in this go back and ARQ low. What will happen if the two messages or three messages not correctly received at the receiver end? It is going to discard. It is going to discard correctly. It is not going to receive the correctly. In that case, it is going to discard that particular frame, total frame 0, 1, 2, 3. In that case, it is going to resend all the 3 frames in that particular window. We have, this is the sliding window, that thing. Whenever we are transmitting the data, the three data 0, 1, 2, it is going to send. Meanwhile, if the data is not properly sent, the total slides would be, the total data will be retransmitted to the receiver end. Okay, in the go back in ARQ. Here you see how the data is transmitted. Go back in ARQ, selective repeat ARQ. You just read all the protocols once again. Okay, if you have any doubts, please feel free to call me. I will guide you. If more number of students are not understanding these protocols, you just tell me through your WhatsApp numbers, and I will rearrange all the things. Whoever not understanding properly, I am going to repeat this session once again, so that you will come to know what is happening. However, there are 2 months of gap would be there, was be there. So you may forgot all the things, but just recollect all the information once again. That's the reason I haven't started new session today. Okay, otherwise what will happen, if I start new section, you are not going to understand each and A and B also. Why? You haven't remembered all the whatever we have discussed in the last sessions. Just try to take some more time, half an hour, 1 hour time. Just go through all the slides, what happens in selective go back in ARQ, what is automatic repeat request, what will happen, what is all the things. This terminology, if you are not remember, you are not going to understand the next sessions also. That's the reason I took this session as a revision session, and I have completed these things. If you are finding that I am not able to understand anything from this, you just ping me. You can message WhatsApp me. I will rearrange one class for that particular people, who those who are not understanding. Okay, just go through all the things. Next, one more announcement. Next week we are going to have the meets. Okay, next week we are going to have the meets. So be prepared for first and second unit, whatever we have completed till now. Okay, first unit and the second unit also. Are you listening, ma? Whatever we have completed till this first 2 units, I have already shared your notes also. Please re-verify all the things. It is very difficult for you also. This is the first day of college. I think so, after 2 months. So please recollect all the information whatever we have discussed today's class, and the notes which you have. If you have any doubts, you can call me. Meanwhile, I will activate one quiz. Please, whatever we have discussed, the same thing I have asked in that particular thing. I'm not going to give you 15, more than 15, 10 minutes, 10 to 15 minutes. Okay. And today what I have discussed, every day I'm going to give you some tips and new things. Today I'm going to tell you something about how you are trusting on any site, google.com or yahoo.com. Why I'm asking you questions, this question is, uh, I'm creating our Gmail account. Okay, I have created my Gmail account. Whenever I'm creating the Gmail account, he's going to give me 15 GB of free space for me, and a mail SMTP server, SMTP simple mail transfer protocol. This because of these SMTP only, you are transferring the mails from one person to another person. The SMTP server is running behind my google.com or gmail.com. It is running continuously round the clock. That's the reason I'm transferring the data from one mail to another mail. Okay, my mails to my friend's mail. Yes or no? And I am saving lots of information. Could you tell me what are the information you are saving into your Gmail? Your personal information. Can you hear me now? Please let me know if you are not hearing me. If I am not audible, please let me know. Oh, okay. This is the Gmail. This is the out of box for making you interesting. I'm explaining you. This is the out of, and it is very useful for you. If you are not finding it is not useful, sir, I know everything. Next time onwards, I am not going to discuss. Okay. What kind of information you are storing in your Gmail? I have generated that thing, email, charankmid@gmail.com. He has given me 15 GB of data, free space in his server, and he's giving services of SMTP, Simple Mail Transfer Protocol. He's using Simple Mail Transfer Protocol, and he's giving the services also on that particular. Okay, Gmail SMTP server details. You see, okay. imap.gmail.com requires SSL. Requires SSL, secure socket layer, port 993. On port 993, it is going to incoming mail. IMAP is going to use SMTP server. Here, outgoing mail. For a outgoing mail, IMAP is using for incoming mail. SMTP, simple mail transfer protocol, using SSL 465 port for TSL, start TTSL, that we are going to discuss in the later sessions. Don't worry about that thing. Here we are using 465 or 578 ports. Okay, I am storing the some information into my Gmail also. What kind of information I am storing in my Gmail? How you are thinking that is the safe? If you want, I will activate your mics also, not a big deal. Security. Yeah, you have unmute themselves option is there. You, if you want to talk, you can talk, unmute yourself and talk, not a problem. This is our class only. No other will come and listen to you. If you are saying wrong also, not a big deal. Are you listening, Nama? Total 93 people. Or other else you are busy in submitting your quiz. Anyhow, I'm going to give you 15 minutes time for 4 questions. Simple, damn sure questions, which are already you have submitted in the last sessions. Hello? Unmute yourself and explain me how you are trusting on Gmail. Gmail is working on SMTP server, that is on port number 465, and TSL, SSL, that we are going to discuss in the next sessions, and your lab. And one more thing I want to discuss you is your lab also. The lab is very different from your regular JNTU curriculum. Very different. And it needs some more installation, as like Ubuntu, NS2, simulators kind of things. In Ubuntu only we are going to execute 6 to 7 programs. Total 12 programs are there. In that 4 to 5 programs you can do online. 5 to 6 programs. I don't think so. Five number I didn't remember, but 5 to 6 programs you can do online, and we can discuss each other as like HTTP, SMTP, and these kind of things. We can discuss SMTP also. I think so. It in the lab manual. Wait a while. I will show you lab syllabus. How you are trusting your Gmail? Yeah, analysis of HTTP, DNS, DSCP, SCTP, ARP, ICMP, IGMP, TCP IP packets, 802.11, 802.14. These are all we can do online. Others, TCL scripts, performance, all this till ninth program we are going to do in college. Okay, first 9 programs we are going to do them in college, or if you are manage your systems with Ubuntu, that's also I will forward you how to install all these things. We can complete this also online. But last 4 or 5 programs, 802.11, 12 performance, they are not, 11 12 also we cannot do, I think so. But 12, 13, 14, 15, this we can do online, and it can be used as identity in all the digital platforms. Okay, one person who is 417 give gave me an answer, good answer. Gmail gives the encryption to the data, and it can be used to identity in all the digital platforms. Okay, there are two things. First one, encryption to the data, good and well and good. I will appreciate his answer, and it is good also. Whenever you're transferring the data, the Gmail will do encryption, and he has the policy of he can access the whenever you are clicking on the next buttons you will click now while you are creating the Gmail, there the policy is there. He is not going to sell this your data, whatever you are storing in your in Gmail. You are storing your contacts, your total information. Personal information is nothing but your contacts and your documents, whatever you are storing in the Google Drive, that are the personal information. You are inserting most of the personal information is nothing but your contacts. Okay, personal information is nothing but your most of the times contacts. While you are connecting to, give me a minute ma, can you hear me na? Please respond. You can hear me na? You have a contract that you cannot. Okay, you he won't disclose this personal information, your emails, your contacts details to any others. Okay, but while you are logging as identity, be used as a identity in all other platforms. While you are using it as an identity in the other platform, it is going to hack your all the contacts, and it is going to misuse your contacts and personal information. Okay, while you are logging at sometimes you will log in with the same Gmail account, you will log into the HackerRank or some other applications. It is going to misuse your digital your information, whatever the contacts you have and your data you have saving in the particular thing. How you are going to find that my data is safe or not? Your Gmail you can trust. Why? While you are submitting that thing, he is going to give you 15 GB of data, and he is going to save your data into his server. Okay, and you will have the contract between your Gmail and you, that he won't sell this data to the hackers for the privacy policy they have. According to that, they are not going to disclose your information to others. But while you are logging into that particular thing with the other Swiggy or some other Flipkart, with you are logging with the Gmail account. In that case, they will access your contacts, your information, Google information, all information, and there may be a chance of hacking your details. How you are going to find out? Is there any technique? My email is hacked or not? The simple answer is, there are so many tools are there or the internet. Just go to have I been pawned. I'm going to paste here. This is the link. Just click on that particular thing. Here there is a email address would be there. I'm going to find search a email ID. That is my email ID, charankshetriya@gmail.com. I'm using, no, I'm not different user. When if you are using passwords, that is a different thing. You are logging as a Gmail account with the login with Google account or Gmail account. In that case, I am saying, if you are creating own log username password, in that case not a big deal. If you are logging as login with Gmail account, in that case, here you see my email ID is pond, sorry, give me a minute. Sorry, it is not Charan Kshatriya, Charan KMIT, I think. KMIT@gmail.com. Here you see one data breach is there. Simply I have to reset my password. That means periodically you change your password. That will help you in hacking your devices. Okay, give me a minute. My chart. Can we use different passwords in the different website? That's good. That is also one thing. But whether your already you have used one more complex, the more complex password is better security it can provide. That is also good. How your password is secure also, that we will discuss in the next. I will tell you how what is the complexity of your passwords also, that we will discuss. But if you want to find anyone, if you are want to check your mail IDs, your mail IDs, you can paste here in your group chart. I will check whether your mails are hacked or not. Please paste your mails if you want to check these particular mails are hacked or not. Otherwise you can check your own also, not a big deal. Okay, 4 data breaches. Rishvi Kandi. 4 data breaches. In the 4 sites you have logged in with your email, they have the access to your all the things. How can we recover if our mails are hacked? There is a hacking is a different ideology, ma. It is not the that means my data is hacked to someone. That means my information is login. He has the login information, all the things. He is not going to do every day and sitting. He is not going to send the emails. Just he will get the extract the information whatever he needs with the help of these particular data breaches. Just periodically you modify your uh, password. He can't do anything. These four sites can't do anything. Okay, these four sites can't do anything with the hacking information. So every period, that means after 15 days or 30 days, you change your password and you be put strong password. Okay. Oh, some other mail got. Oh, Siri Chigiri, 1941. You haven't pawned, your password is very strong, so you haven't logged in with any other site, so your data is very safe without any issues. You can continue the same password. Keep strong password and don't give any logins while you are logging into the any sites. You don't allow them to access your contacts, otherwise they will access all the contacts of you, and they can do some misplaces. That means I have the email id na, this email id I can send any email with the help of this without accessing you also, without accessing Gmail also. I can send the same email id as like Siri Chigiri 1941 to others. There are the sites are there on your online. Okay, with that we can send as like Siri, how Siri is sending, I can send the email to some others. That we will see in the next things. Okay, but if you are finding any somewhere else, if you are sending thinking that my data is, my email is hacked, please check here and change your email password. Keep a public password, not public password, keep a strong password so that no one can access. Periodically change your passwords. Okay ma, but I'm stopping your quiz. See you tomorrow in the morning, 8 o'clock sharp.